Hi, my name's Denis Stretton. Welcome to the world of multi-rotors. We're going to be bringing you an insight as to what's available, what to buy, what they're used for, safety rules and regulations, and how to fly them. So let's get started into what's available. We're lucky enough today to be able to use the wonderful facilities here at LHC Leamington Hobby Centre, which is just outside of Banbury, and as you can see we've got fantastic facilities that enables me to show you a lot of the kit that we're going to be flying today. And basically, if you're going to get started into multi-rotors, you'd start with something along this sort of line, which is a electronically stabilised, off-the-shelf, ready-to-fly aircraft. This particular one is the LA Trax or Trax Alias. It comes in a variety of colours. We've got the orange one, but it comes with green, blue, and to aid in orientation, we've got the different colour props. The two orange ones are the front, and the two black ones are the rear, and we've also got a light on the back. This is quite easily controllable. It also comes with the included controller, which has a bit of feedback on it, and shows you the battery state, and also shows you the battery state of the aircraft. Very stable model with 3 levels of stability. For the totally uninitiated, we've got high stability mode, which means the aircraft won't tip more than 15 or 20 degrees in any direction, which will mean that it won't get too far away for you to lose it. If you let go of the sticks, it will stay level and won't fly off. It's also quite crash resistant. It's got flexible props, low inertia, very soft malleable body, so if you do hit a wall or hit obstacle, your chair, if you're flying indoors or a table, it won't do any damage to either the aircraft or whatever it hits. I wouldn't recommend flying it around people or near to people because these do spin at quite a speed, so they can cause scratches and cuts, so be careful when you're flying. Once you progress, you can turn the stability level down a notch, which gives you more control, so you can tilt it, and you can also pre-program tricks. As your skills improve and you can fly in circles and figure of eights, you can turn the stability off completely and it will fly like a model helicopter. That means that if you set it off in a direction, it'll continue flying in that direction until you fly it back. Much more difficult to fly, but you have the ability then to hit a button and it will self-stabilise again. So as a beginner, price and ease of use, very good place to start. These are available in a lot of hobby shops and can be available on the high street stores as well. A lot of the time, multi-rotors, or quads as they're called, are used to carry a camera. And here's a little example of that, which is the Blade 200QX with its controller, and you can see underneath a nice little small HD camera. And this can be flown indoors or outdoors in a light wind and take quite nice aerial footage. It can be of your garden, your pets, obviously not getting too close. You do have to be aware of where you're flying. You wouldn't want to be flying this over your neighbour's property or in the main road or anywhere where there's vehicle or people about. So it is quite relevant as to where you fly it. Usually you would fly it in a safe area and you'd have somebody with you spotting so that there's nobody walking into where you're flying and causing danger. The controls for this are very much similar to the beginner's one that I showed you earlier, but this is less stabilised and flies like a proper model helicopter. This is a Mode 2 transmitter where all the main flight controls are done on the right stick. To bank the aircraft to the right, you would move the stick to the right. The 2 left motors speed up and the 2 right motors slow down, and the aircraft will tilt to the right. If you want the aircraft to tilt to the left, move the stick to the left and the aircraft will move to the left. To go forwards, you push the stick away from you. The rear 2 motors speed up, the front 2 motors slow down. The nose will tilt down, the thrust will drive it forwards, and the same for coming backwards. The rear 2 motors slow down, the front 2 motors speed up, the nose will tilt up, the thrust will drive it backwards. In the hover, or when it's stationary, The aircraft is always moving and you have to balance its position by constantly moving the stick. So if it starts to move to the right, you pull the stick to the left and back. If it starts to move backwards, you push the stick slightly forwards. The altitude is controlled by the throttle stick. When the throttle stick's down at the lowest point, the motors are stopped. To take off, you push the stick away from you, the motors will speed up and the aircraft will take off. When you're at the height you want, which is usually when you're learning 2 to 3 feet, you stop moving the stick up and you control the height by moving the stick in small increments up or down. If it's climbing and you don't want it to, you pull the stick towards you a little bit. If it's dropping and you don't want it to, you move the stick away from you a little bit. The rotation, or the yaw control, when you want the nose to rotate to the right or to the left, is done on the left stick. To rotate to the right, you speed the 2 anti-clockwise motors up and slow the 2 clockwise motors down. That's done electronically on board, and what that does is it creates a torque reaction either to the right or the left. To rotate the nose to the left, and bear in mind you'll be looking at the nose all the time, not the back of the aircraft, so you want the nose to go to the left, you push the left stick to the left and the nose will rotate. Following on from the Blade 200 that we looked at earlier, we have the slightly larger model, which is the Blade 350QX, and this enables you to carry a bigger camera. In this case it's a GoPro, which does HD video and stills. It's a heavier camera, therefore the bigger aircraft. This one is on a fixed mount with rubber dampers to take the vibration away. All the controls are the same, and in fact you can use the same transmitter, in this case the DX9 Spectrum, but what you can do is it will save various models in its memory, and it will not allow you to fly the wrong model, because as the models are matched to the model memory, you can't fly the Blade 350 when the Blade 200 model is selected. It's all done in the computer program. You would select the next model, tell it to load those parameters, and you fly this using exactly the same transmitter, which gives you the same feel, the same sort of control response, but you can set everything up individually for each aircraft.
This has GPS stabilisation. As you can see from the green light on the back, this means that it's in GPS mode. And the GPS system keeps the quad exactly in the place where you've left it. So I'm not holding the controls, it's just flying itself. But what this does mean, if something disturbs the quad, it'll try and go back to where it was before. So you can see the GPS knows where the vehicle should be, and any disturbance it measures and sends the quad straight back to where it's supposed to be, on the original place. Okay, here's a demonstration of the return to home feature. At the moment the vehicle's hovering on GPS, so it knows where it is, it knows where its home position is. So if we just push forward, move away and up, we'll stop over there and we'll spin it round so it hasn't got a clue where it is, and we press return to home. Here it comes. So it comes back at a set height to where it knows is the home position, and then lands itself.
I've got with me my good friend Paul Wilson, and we're moving on from the more basic models up to a more advanced model. This is the DJI 450, and in fact this used to be my model when I first started, and Paul's taken it and modified it. Paul, could you talk us through some of the features you've added to this and the control systems and that sort of thing, please?
It's the standard DJI NASA system, but I wanted to learn about flying with a camera.
Okay.
The standard, I've moved the camera away from standard. As you can see, I've moved it towards the front of the aircraft and lower, so you don't see the props when moving in forward flight. And also, I've built some retracts for the aircraft as well. So when the camera is panned down like that, I can also move the retracts out of the way for getting aerial images at a low budget rate, as opposed to the big DJI that we've seen earlier on.
But this has still got the same GPS systems and the position hold.
Basically, it has the DJI system. So yes, it has GPS, turn to home, takeoff and landing, intelligent orientation, the same as the A2 as on the 1000,
okay,
but all within the 450.
And these retracts you made yourself out of, are they aircraft retracts modified?
No, they are Horizon retracts that I've modified with some carbon fibre tubing and a bit of aluminium from B&Q. But yes, built them with some cheap bits that I bought from China.
Could you show us them working again, please? So you flick a switch on the transmitter.
I can flick a switch on the transmitter to operate the retracts, and I've also configured the radio so that I can pan and tilt on the camera, but also as well I can adjust the pan and tilt on the knob on the radio as well, so I can see a lot more from the air.
And the camera's obviously on a gimbal that's stabilised, so if the aircraft is being blown around in the wind or flying in any direction, if you're doing a bank turn, the camera will maintain its position. So that's independently stabilised apart from the aircraft.
It's intelligently stabilised, and I've been extremely impressed with the images that this system has given us.
And the flight time on this as well, what sort of flight time?
I'm nearing the capacity of the DJI 450 with the 3S. And I'm probably not getting much more than that 6 minutes flight at the moment. That's with the undercarriage on as well, and obviously the GoPro being powered as well.
So obviously the more weight you add, the less flight time
Absolutely.
You've got. Yeah, right. So you pay the price with having all of these gadgets on. Remember, if you're going to take this up as a profession, you do need to be qualified and pass the certificated course called the BNUX, and you do need permission for aerial work from the CAA. If you're going to charge any sort of money, or if you're going to do it for reward, your normal insurance won't cover you for that. There are certain things you have to comply to, regulations that you have to adhere to, and checks that you have to do. So be aware that if you are going to do it professionally, your standard flying insurance will not cover you for that. I've also got with me today Nigel Cartwright, a professional model maker who writes for a couple of magazines and does articles. And Nigel's got basically a self-built using parts from auction sites and off the internet. Nigel, could you tell us a bit about this, please?
Well, this is a sort of a home built from bits and pieces. 2 energy motors, 3DR RG Pilot flight controller with a GPS and compass on the top. There's a radio link back to the laptop so I can set up waypoints for the airframe to fly autonomously around a preset course, and you can make it take off, land, fly a set course, go wherever you want,
And have you got video feedback from the camera when you're doing that? What will be the purpose?
It will have. There will be a camera gimbal.
Oh, so this is still still being
put together.
And could you tell us a bit about the ArduPilot? Is that open source?
It is open source. Yes, a lot of people contribute to the software. It's constantly being updated. Very capable. It's capable of taking different sensors, ultrasonic height control. GPS, as I say, on the top.
But internally, it's got your standard 3-axis gyro, accelerometer, barometer,
exactly,
magnetometer. So all of that is included.
It's standard stuff, but it's as I say, it's open source. It's put together by people all over the world.
And then you need to obviously flash the memory with your particular setup, set up the gains and PIDs.
You can change all the settings on the laptop,
okay.
And it's, as I say, it's linked through with the radio.
So there's a bit more of an advanced than your ready to fly or almost ready to fly DJI Phantom or Blade 350.
You can get into the settings deeper. That's and tune it more to what you want it, how you want it to fly.
Would you need to be a computer expert to be able to do that, or is it pretty intuitive?
No, it's totally intuitive. And in fact, the software that comes with it runs on Macs, PCs. There's Android setups as well.
And tablets. Also, I suppose, like anything else, any information's out there on various forums, on the internet, YouTube, things like that.
That's right. 3DR have a very good wiki page with all the instructions on. So
3DR or 3D robotics.
3D robotics.
This has been superseded now, is it, by the Pixhawk?
The Pixhawk. The Pixhawk is the same functionality, but a much faster processor, and it'll have inputs for better sensors and so on.
Which is ready to fly basically out of the box. This is the DJI Phantom 2 Vision Plus. It comes, as I say, ready built with the camera, with a gimbal on it. The gimbal is all preset. It's a bespoke camera, and it comes with a transmitter, with an Android app or an Apple app that you can actually fly and control a camera from your phone, and you can also see live output from the camera on your phone. You've got full control of the camera functions, tilting, panning, which is done with the aircraft, and you can take stills and video and control all of this from the phone. Very stable. It's got all of the features of the previous models, which is GPS stabilised. It can be flown in GPS or what we call manual mode, which is stabilised but not self-holding position. And you've got the safety features of return to home, orientation control, and fail-safe landing in case of signal control loss. It also knows its point of takeoff and will return to home in the event of failures of that sort. The app will tell you how much battery capacity you've got left, and will give it an audible warning to say return and land as soon as possible. You do have approximately 15 minutes flight time with this, which is quite a long time, and then you do need to really think about landing it. Very stable, even in comparatively strong wind. These are available now directly off online stores and even in Maplins. You can buy this at Amazon or Maplins or your local hobby shop, obviously. And this is ready to go and gives very, very good quality footage for the aspiring professional film operator. You do need to be very aware of where you fly it. Again, there are videos of people flying at weddings or parties. This is totally unsafe and shouldn't be done at all. Although they're not heavy when they're flying, they will cause serious injury if they were to fall on somebody's head. And this is very irresponsible and is not to be condoned in any sort of way. I've got John Tanner, editor of Model Helicopter World, with me today, and he's going to explain a little bit more of what quads are capable of. We've seen the introductory models and the camera carrying capacity and how that all works, but they've developed into being able to do aerobatics and fly inverted. John, could you tell us about the model you've got in your hands there, please?
Yes, certainly. This is the InvertiX made by Encore RC, which is an American company headed up by Bobby Watts. And this is arguably the world's first fixed pitch, invertible capable or 3D capable quad. Basically that means that it flies this way up normally, and that by some very clever electronics and very powerful speed controllers, it can actually fly upside down as well by the rotors reversing direction. So that's what makes it the first. It flies off, originally it was flying off 3S LiPos, and they've now increased its power by actually flying it on 4S LiPos, which makes it virtually fully aerobatic and fully 3D capable. We've recently reviewed this in the magazine, Model Helicopter World magazine, and we've got some great photographs of that on the front cover. They're actually flying upside down and performing all the stunts that you can possibly imagine. And that's basically it. It's developed really by these props, which are very, very thin, very not sculptured, not really airfoil section, but that's one of the tricky parts of it, was to actually develop a prop which will actually still produce thrust in both directions.
So you wouldn't be fitting a camera to this or using it anything but fun, really?
It really is just a pure fun machine, perhaps aimed at the RC pilot who wants to just see it. And it's also about what's capable, what's possible now, because originally quads flew right way up, flying around, then they started getting faster, then some of them started to be able to do flips and things like this. So this is an extension of that.
So this is sustained inverted flight as opposed to just a simple loop or roll or flip.
Yeah, exactly. I suppose the other thing about it is that it's a relatively cheap option because it's a fixed pitch prop, so it's just all done electronically. All that's happening is that when you want it to be upside down, is that you are reversing the props, which just means a very clever and very powerful speed control, electronic speed controller, which is able to stop that and restart it really quickly.
And I presume by not having the mechanical systems, you're saving weight as well as being less complex.
Yeah, that's it. I mean, there's no mechanical linkages involved in this, which is what makes it simple and obviously that much cheaper to produce. So therefore, and it makes it pretty rugged as well, to be honest, because as I say, you haven't got any linkages, variable pitch props, you haven't got anything like that at all.
Yeah.
So it's just what you see is what you get with it.
And this comes almost ready to fly out of the box, does it? Do you need your own transmitter, or do you get a transmitter with it?
No, it comes as a kit which you then have to assemble yourself, which is all pretty straightforward. It's all carbon cut parts, or there's a slightly less expensive version which has got G10 frames on it. The kit contains all of the parts you see here, all the speed controllers that you need, and it's got its standard board as well, which is preset. You need to be able to supply a 3S or preferably a 4S pack, because that works better on the 4S pack in all honesty, and also a receiver of your choice to be able to tie it into your own transmitter. But it will fly off a standard transmitter, nothing fancy is needed whatsoever. It's a lot of fun, and it will put a silly smile on your face.
Excellent. Thank you very much, John.
Okay, you're welcome.
Hi John, I see you've got one of the early models with you today. Could you explain to us how it all started and how it's developed on from this sort of model, really?
Yeah, basically this is it's the Dragonflyer, which is a company which started up producing some of these quads about 12-14 years ago, and they got in contact with Model Helicopter World magazine, which is how I got involved. And the first one was a foam model, which unfortunately I don't have anymore. But this one they sent to us a little while later, and we reviewed this about 12 years ago. So it gives you an idea of the age. So this was really cutting edge stuff at the time, because it was, as far as I'm aware, the first commercially available model which actually had a camera on it, which is this one here. And this was completely new to us then, and we had no idea it was possible. And essentially this worked with its own little aerial here, and there was a receiver which you then had to connect into a television or a monitor of some type, and you can actually get the picture. It's on very short range, pretty fuzzy, but it worked, and arguably perhaps set the sort of the scene, if you like, for what you've been seeing nowadays, where everything's much smaller. It worked on 35 megahertz, so it's a very old system from that point of view. We had very small batteries. This is the battery pack here, which is rechargeable. It would only fly for about 2 or 3 minutes before the battery was flat. You can see the motors were very what we call can motors, so they are not particularly efficient, running through this geared system in here. The blades are all made out of foam, so you get an idea of that. It was quite advanced because it had a couple of LEDs on the front, so you could see which was the front, because otherwise, well, if you could see those, it meant you were flying nose in, which wasn't necessarily a good thing in those days. So it's just an example of how things were then. If you look at the electronics, you can see, how can I show you, these long sort of tins here, one there, one vertical, and another one here. Those are actually the gyros. So each one of those is a gyro for the 3 axes of this particular model. And it's only in the last sort of 12 years or so that we're now seeing these gyros all put into a tiny little chip, which allows the small stuff which you've also seen in this production. And you can see how the electronics are actually surface mounted around here, but big electronic components, extra bits soldered on. So it just gives you an idea of how early it was, but that was only about, well, as I say, I think we produced the article in about, what did we say, about 12 years ago.
Yeah,
so
2002,
and
2003.
it just so happens I still have it, and it sort of sits in my office as a reminder of, well, perhaps where this stuff came from.
So more or less everything has changed now. The battery technology's moved on, the motor technology's moved on, the gyros, the electronics, everything's moved on tremendously.
Absolutely, but the principles are exactly the same with this as they are with any of the other products you've seen on the latest. I talked earlier, or we'll talk about the InvertiX. The principles are exactly the same. Fixed pitch props, changing RPM to be able to control it in vertical pitch and yaw controls. So
And what was it like to fly? Was it a handful to fly? Was it fairly stable? Obviously, we're comparing it to modern technology now.
it was actually surprisingly stable, very slow to respond, but it actually sat there and did what you wanted, albeit, as I say, slowly. If I remember rightly, as you used it to apply different levels of cyclic control over it, you could actually see the props bending under the load, because as they slowed down, then suddenly the load would go up and they'd start going into dihedral like this. So you get an idea of how sluggish it was, but it still sat there, and we did get some footage. And I seem to remember when we published the article, we got a photograph from somebody's lounge, television in somebody's lounge, where we were actually watching what it was. So I was outside flying it, and my friend was inside taking photographs with his camera of the television screen.
I've seen the photograph, yeah, and you're right. This model, please. This is the Parrot AR Drone 2.
This is the Parrot Drone 2. This was one of the first commercially available quadrotors. The difference with this model is that you don't use a transmitter to fly it. You use a iPad or an Android tablet. This model is fitted with GPS.
Yeah.
In fact, if we lift the top off, there's a GPS receiver in there.
And we've also got a camera on the front.
And there's a camera on the front. And from that, we can see the view obviously from the camera.
Yeah.
And we can also use a map, downloaded map, to set a waypoint that the model will fly to and fly back home again.
And you can do that just by clicking on the map and
just by tap, and the model will go to wherever you've tapped on the map.
And can you operate any features while it's there? Do you tell it to take a photo and it will come back? Or?
Yes, you can take video, you can take photos, you can store photos and video on a USB stick. There's a big online community, in fact, that Parrot have organised, thousands of members who share videos, photos from all over the world.
And am I right in thinking this has got a downward facing camera, so it's slightly lower resolution? It also does, is it sonic height control?
It's sonic height control.
And what that does, I believe it keeps about a metre above
the ground. Well, whatever height you want to set.
Yeah. Yeah. Oh, you can set the height then. Yeah. And that will self-stabilise and lead in that position.
Yep.
But you can do your flying
and then you set a
here.
waypoint, you press go, and off it goes. Yep.
And what about standard normal flying? Can you do that with the?
You can.
And would that be by motion, or would it be
both? There's sticks on screen, or you can use tilt, and it'll fly from that.
Multi-rotors are often used to record aerial views of historic sites and landmarks. This is Stowe Maris, Europe's largest surviving World War I aerodrome, and the 100-year-old buildings are now being protected and restored to commemorate British aviation in the Great War. These views show how, with a relatively inexpensive multi-rotor camera platform, you can record superbly stable HD video that would cost many thousands of pounds to acquire in any other way. It was filmed using the DJI Phantom 2 Vision Plus. I have with me today Philip Terry, who's the chairman of the Association of Remotely Piloted Aircraft Systems UK. Philip, could you tell us a little bit about ARPAS and what it's aimed on, what you do?
So it is the Association of Remotely Piloted Aircraft Systems, as you said. We represent operators and manufacturers of commercial ARPAS, otherwise known as drones. And we are working very hard to, essentially, the overriding objective is to grow the industry, and we want to, of course, do that safely. We want to do that sustainably. So we take care of a number of parts of the regulation. We try to raise awareness in other operators and in hobbyists who perhaps want to move into the industry as well. We have fantastic connections with the CAA. We sit around a regular safety partnership meeting, and we discuss the appropriateness of the regulations, the future of how we're going to go about growing this industry sustainably, essentially, because there are an awful lot of people now coming into this, and we want to make sure that when they come in, they know, or they're able to consider all of the aspects that are involved with entering a professional aviation industry.
And are you at all involved with the hobbyist and the amateur side? So shall we say the amateur side, the sports photographer, or are you more to do with the professional side and liaising with manufacturers and regulations, as you say?
So the focus of our membership is professional commercial operators.
And would this be large companies, or would it be one-man operators?
SMEs, so small to medium enterprises. There are a lot that consist of 1 to 2 man bands, depending on the market they're focusing on. However, there are more and more very large commercial companies coming into this who have exactly corporate size, and we have a membership package to suit whatever or whoever you are.
So basically the pilots would have a CAA permission for aerial work and have passed a qualifying flight test and ground theory course, and you'd be liaising with those sort of people with the CAA and manufacturers and operators and people who want to use these.
Exactly. Yeah, exactly. Although we're here to help the industry grow, we're willing to, we want to encourage people into this industry, and we want to support them and nurture them in developing their professional outfit. So we will take on people who don't have permissions and don't have the qualifications yet, but we are there as a resource and in a network for people to come to us and get advice and understand how best to enter this market and what they must consider when they're thinking about doing it. So it's not just about the safety side of things, the qualifications. It's also about how are you going to grow your business? What market are you going to enter?
Okay.
And when you consider taking on the aerial industry, you've got to consider, of course, how many average flying days can you do per year? What are the chances of you being able to get that? And how much are you going to have to charge per day in order to make a turnover that will sustain you? So we obviously represent a number of professional operators already, and that resource and knowledge can help support newcomers to the industry to help them grow and to start a business.
But you've got no affiliation with any particular manufacturer or supplier or anything like that? You're
entirely independent, and we're a limited liability company that's not for profit, and that's the only way that the CAA would engage with us anyway, because in order to be taken seriously, they don't want to consider that there's any bias.
Yeah, which is a good thing, really. Yeah. You're not going to be promoting one manufacturer over another. People will make their own decisions based on sound advice.
Exactly
basically.
that. One thing I want to pass back to everybody is that there's not, say, ARPAS is the association for everybody in this industry, for every stakeholder, for anybody interested in any aspect of it. So operators and manufacturers are our focus, but we're there to help consultants come in and give advice on, say, insurance or health and safety aspects of operating. And we're there for hobbyists who consider that they want to come in for professional. So what I try to emphasize is that it's the association for the industry, and everybody has the opportunity to be an ambassador for the industry at the same time.
Yeah.
So
you've got a database of members, and you can
Yeah.
network with other members and
exactly.
feed off of each other as well. So, okay, that's good. That's
Yeah.
good. Philip's involved in a lot of broadcast quality work in the film industry and TV, and he's brought along one of the professional pieces of kit he uses in the industry. Philip, could you tell us a bit about the kit you've got here and show us how it works and what the various features are, please?
Sure. So this is the DJI S1000. It's got a maximum takeoff mass of 10 kilos, so it can carry a sizable camera. You're talking, say, as large as the Canon 5D.
Yeah.
Its average flight time, depending on its configuration, is around 10 minutes. And you can see it's got 8 rotors here, so it's an octocopter.
Yeah.
It's in a flat configuration, and you've got various features which enable us to do professional work, such as the retractable landing gear, which will remove from the shot so that you can do full 360 panning.
Yeah.
You've got the DJI A2 flight controller, which gives you a very accurate flight control system, which has built-in GPS so that it will position hold and do various other position qualities like course lock and intelligent orientation control.
And that's a stabilisation system as well, so that'll
Exactly.
keep the aircraft basically level until you tell it where you want it to go.
Right.
Okay. Yeah.
So rather than manual flight, it's more like you are directing its flight path
Okay. Yeah.
with intent.
And you do that on obviously one of these
Exactly.
transmitters. Yeah.
So when you enter, or depending the level of the market you're entering commercially, the quality increases depending on the camera that you carry
Yeah.
and the number of operators in it. So in order to be able to say, if you start tracking cars or people in various shots, the ability to be able to independently control the camera from the aircraft enables you to get much higher quality footage. You have the aircraft controller
Yeah.
and then the gimbal controller. And here, if you pan left, it will pan left. If you pan right, it will turn right. You can then obviously go down and up. You can also control roll, but of course for most footage you always want to be level,
You want
don't
it to
you?
be level. Yeah. Yeah. Philip, this is quite a big machine, large diameter, bigger than your average model. How easy is it to transport, and what are the practicalities of moving it about on professional work?
So DJI have specifically designed this to be foldable, so you can see just as quickly. You can fold the props,
Yeah.
And fold down the arm.
Yeah. Yeah.
and now you can do that with a complete system, and you can see it will then fit in a box that is below it. One of the major advances of transporting it in such a well protected case is that you protect the integrity of the aircraft in transportation. Now that's not just for sending it abroad when you do foreign operations, it's also for when you're carrying it from, say, location
Yeah.
to the next and carrying it in your car. So rather than it being loose in the car and potentially being bent, or the props being bent, or say one of the arms being hit a little bit, you're able to put it inside a case where you can ensure the integrity of the aircraft, so that when you take it out to do the next operation, you don't have to be concerned with anything, structural.
Okay. Okay. And obviously everything you need then would be in one spot. I'll presume your batteries, your transmitters,
Yeah.
is all in one place. Generally you won't get somewhere and have forgotten your batteries. It's all in the case.
That's one of the biggest practicalities, is the fact that it's a one-stop shop for my case. I can put that in the back of the car and always know that I've got everything
You've got
I need in
everything
it.
together.
Before taking off, of course, I would check to make sure that all the locks are in the correct place, that they are all secure, the props are all out straight, and the GPS puck is up, and everything is physically well connected together.
Okay.
Before takeoff, once I've initialized the motors, I'll put in some input, forwards, backwards, left, right, to make sure that the directions of the motors are correct, so that when it takes off, I expect that forwards is still forwards. So I can do a quick demonstration of that now. So that's right, that's right, so it's lifting on the left. That's left, so lifting on the right. That's forward, so lifting at the back, and that's backwards, so lifting at the front.
Okay, so we can see the aircraft tilting basically in the direction that you're pushing your control stick. Okay. And we've got the flashing light there. That's telling us what?
That tells us the flight mode we're in, whether that's GPS, stabilised or fully manual.
Okay.
It'll also tell us if there are any red lights, where the number of GPS signals that it's receiving, and it will also warn us when the batteries are running low.
Okay, good.
Before taking off, I'd also make sure that the ground is secure, that nobody's going to walk in and around where I'm intending to fly, and of course that there are no other air users in the vicinity that I could potentially collide with. So my second camera operator would act as my spotter to help watch for other air users, which I would need to avoid, and which is the whole point of flying visually.
Okay.
Okay, so I'll go for takeoff now. Once I've taken off, I'll fly to 5 meters above ground and retract the undercarriage, and then do some flight demonstrations as to the different flight modes. Okay, so we're at 5 meters, we've lifted the undercarriage, and now I'll give you some demonstrations as to the different flight modes. So at the moment we're in GPS, which means essentially it will hold its position that was recorded at the last throttle and stick input. So at the moment it's holding there entirely by GPS location. I've got the throttle at 50%, which is automatic hover. Okay.
And that will hold its altitude and its position.
Yeah, exactly.
Okay.
So now if I switch it into ATI mode, which is stabilised, you can immediately see it starts drifting.
It starts to move away, yeah.
Yeah. Now that's because of crosswind. That's not because I've given any inputs yet. That's just purely because of the wind and it flying about.
Aerodynamic forces. As
yeah,
such.
exactly,
Yeah.
exactly. So I can now counter that by giving some input. So I'm flying forwards and to the right now. And you'll see it will continue to drift. As soon as I enable GPS mode, you'll see it will immediately stop and try to hold position. So here I go, a little bit faster input. You can see it's still drifting, engage GPS.
And that's
And it
the
holds
aircraft
itself.
doing that itself. You didn't have to do anything but throw the switch.
Exactly,
And it'll stay there again until you can override the GPS and move it to where you want it.
exactly.
Okay.
Now
good.
it has certain wind tolerances, and I believe in the DJI manual it's around 18 meters per second of crosswind that it can fly up until.
And that's about 12 to 13 miles an hour. Something like that.
Yeah.
Okay.
So now you can see it's flashing yellow lights.
I see, yeah.
Okay,
Yeah.
that means that it's now running low on battery. I shall bring it home, lower the undercarriage first, bring it home and land and change batteries.
It's quite difficult, the orientation there, but with that flashing light you can see that it's facing you,
Yeah.
or the light's facing you. Philip, could you show us a couple of the typical camera angles and tracking shots that you might do with an aircraft like this? If you were on a film set, for example, what would they ask you to do and how would you achieve that?
Okay, so doing my usual pre-flight checks,
All clear.
take off, reduce, lift the undercarriage, I'll come back down. Now, one common shot I'm asked to do is often to start low, hover, and pull up and track backwards at the same time. Now, to do this, I fly in ATI mode because it enables you to be a bit more fluid with a shot. So say I'll hover here, and then I'll increase the throttle and I'll lift at the same time. And that creates a really nice general view of whatever the subject was that you were filming before.
So you've got a dynamic shot incorporating movement and a wide angle.
Exactly. So one of the advantages of these aircraft is that it presents the opportunity to go from eye level to, eye in the sky, and no other filming opportunity presents that. No other camera, piece of equipment can offer that kind of flexibility. So now say I'll demonstrate, I mean, it doesn't look much, but just to do a side tracking shot of, say, a car driving down the drive or something, you know, in order to replicate that shot, you would have to create a dolly tracking system on rails, which is very expensive and difficult to set up. Whereas you can see immediately this aircraft can fly a very accurate, stable shot, especially with the gimbal that's underneath it, and produce opportunities that have never been feasible before. Because you can fly so close to things, but then go so high as well. So, say just a general pull-up shot can involve, you know, hovering at a single point. At this point, I'll use GPS because I then don't have to worry as I lose orientation of the thing ascending that it stays at the same location. And I'll just floor the throttle and see what kind of shot you get that way as well.
So you'd have a top-down shot, the subject would remain centrally placed without you having to do too much of the controls positioning.
Exactly.
And your camera operator would be able to do any fine control of angles and that sort of thing without any interference
Of the pilot. Exactly.
Yeah.
I can concentrate on what I need to focus on, and the cameraman can focus on what they are trying to capture.
And I see the descent rate is very well controlled, so you can vary the climb rate and the descent rate
So when
into the shot.
When you descend with a multi-rotor, the trouble is that you pass through your own downwash, so you get a bit of wobble of the aircraft. It doesn't descend as well as it ascends, of course. So going up, it's nice and smooth, but if you try coming down quickly, you'll see the aircraft buffets about, and the shot isn't quite as nice or as smooth.
The best way, purely the aerodynamic.
Yeah, exactly. The best way to get around that actually is when you're descending, that you descend with a bit of a track at the same time, so you're not passing through your downwash and you're coming down at an angle instead. It enables you to come down much faster.
So you could be tracking a vehicle, you could be tracking a moving object quite close to the ground as well.
Yeah, exactly.
Now the orientation at that sort of distance is quite difficult, but you do have some kind of assistance on the control system that it will orientate itself according to the stick movement, not necessarily to the way the aircraft's flying.
In relation to the position of the original home point, yeah. So if you're standing close to where the original home point was, it will, no matter what the orientation of the aircraft, it will return to you with your back input.
So you just pull a stick towards yourself and it knows where it started from and comes back no matter which way the aircraft's facing.
Yeah,
even
exactly.
if it's pirouetting.
Yeah.
That's an interesting shot there. It's backwards tracking, low to the ground.
So I can demonstrate that orientation control. We can fly a decent distance away. Say we want to film this tree and I've lost orientation. I'm going to turn it now until I personally lose orientation. So I'll engage orientation mode. I'll bring it back to me.
Now the aircraft's flying sideways towards us even though you're just pulling back stick. It knows the centre point.
Exactly. There you go. So now it's closer to me. I can see that forwards is almost towards us. I can rotate it.
Get your orientation back.
Done.
And you're back to normal flying mode.
And look, yellow light is flashing, so it means it's time for a battery change. Landing gear down, and I shall land.
If you were a long way away, what would happen there in that situation? Would it land itself? Would it return to home?
So you can actually change the settings. You can tell it either to land itself directly below that, or you can tell it to give you an early warning, which is what we've chosen. So it gives you more time to bring it back home.
But obviously by being aware of the time and making a note of that, you make sure that you get within those safety parameters.
And when I'm flying, personally, from a sort of skills point of view, I will always remember what inputs I've given the sticks and be able to relate that to the position and the orientation of the aircraft. So I actually find it difficult to lose orientation by using that.
Yeah.
I essentially imagine myself sitting on the aircraft and always looking forwards.
We're now going to talk about my own personal machine. This is the DJI S800, fitted with the Wukong M flight control system. And I've also been kindly sent by Desire RC their latest LEGO gimbal, which is configurable for a number of cameras. Personally, I'm using the Canon 100D, which is one of the lightest DSLR cameras available, and that keeps down the aircraft weight and gives you overall better flight performance and flight times. The LEGO system is configurable for a number of different cameras. As I said, you've got a number of different adjustments. These are slotted here. We've got slots on the back so you can get the centre of gravity right, and it's very important with a gimbal to get the balance of the camera right. I can show you this in a number of ways, but you need to find the centre of gravity of the camera to make sure that when you let go of the camera it doesn't tip in any direction, either forwards, backwards, left, right or up and down. And then what that gives you is the ability to set the gains of the gimbal to stop the camera bouncing around and be able to be controllable in all kinds of winds and when the aircraft moves. We can see if I tilt the camera there, it will come back to level. If I push it down, you'll see a bit of jerking, but it'll come back to level. I've also got configurable on this system, which is using the Alex Moss board. I can tilt the camera down remotely from the transmitter. I'm using the Futaba 14MZ. I can rotate the camera left and right. Normally I wouldn't do this because I could just rotate the aircraft using the rudder stick. And I can also compensate for any out of alignment on the horizon by altering the roll. Again, normally you wouldn't do this. The aircraft and the stabilisation system will keep the horizon level. I've also got a remote control which is triggered from another switch on the transmitter via an IR remote on the aircraft. If I do that, the camera will take a picture, and I can do that remotely while looking at the FPV screen. The gimbal's got, as I said, the Alex Moss base cam controller on board, which is configurable via Bluetooth and a laptop using the application. On the application you've got a basic screen, and when you initially set it up you've got an auto facility to set the power of the motors. The motors can deliver enough power to control the camera through the angles, but you don't want it overpowered because that'll use up battery power, but you want it strong enough to compensate for any wind and deviations of the aircraft. Then you then have an auto tune facility on the left, which allows the software to configure itself to react to the aircraft movement and to wind gusts in the right manner. You can set various features up, such as whether you want advanced roll and pitch angles. As I've stated on the remote control, I can turn the pitch down, I can turn the camera to face down, and I can control the speed and its reaction timing from that. We can also configure any inputs, such as remote shutter operation through an RC tab. We can configure the battery voltage and the warning systems that it gives you. We've also got a monitoring screen which shows the feedback from the various sensors. We've got a set of gyros and accelerometers built into the camera gimbal. If I move the camera, you can see the feedback on the screen, and by configuring the setups on the basic screen we can get that to be as steady as possible to react to any camera movements. And what that does then is, when set up properly, we can check the action of the camera by lifting the aircraft up, and as you can see, any movement of the aircraft is completely compensated for by the software in the gimbal. And this works very well when flying. The aircraft can be buffeted around by the wind, but when you've got your on-screen display, the image stays absolutely still. The secret to this is getting the camera perfectly balanced with a correctly matched setup of the software. Well, today we've covered the basics of starting in multi-rotors, buying your first multi-rotor, the kind of kit to buy, then progressing on to the more advanced systems with cameras, onboard flight controls, return to home systems and fail-safe systems. And we've also moved on to the professional use with high-end professional kit such as the one I've got in front of me here, with the stabilised gimbals and higher definition cameras and more professional style cameras. We've also covered flying for fun with FPV, 3D capable quads as you've seen, and the general fun that people get out of enjoying the hobby. What I'd like to finish off with really is a point on safety. Obviously these things are freely available in a lot of stores and online, and people get the idea that because they're ready to fly you can fly them anywhere. There are certain laws that are applicable. Safety is very important. Make sure that you're flying in a safe manner, that you take all the safety precautions that are in the operation manual. And if you need any advice, you can always go to your local model shop or look online at the forums. The other thing is insurance. Mostly your household insurance won't cover you, and you would need public liability insurance, especially if you're flying outdoors. A good place to go for all sorts of assistance, both with multi-rotors and the law, is the British Model Flying Association. It's quite cheap to join. You get membership for the year, and you get up to £25 million insurance cover, which obviously means that you don't want things to go wrong, but you have got the cover if things should happen to go wrong. So remember, I hope you've enjoyed our little video. Have fun, but most of all, fly safe.